Hello, good morning, good afternoon, good evening, good whenever you're watching this video. Thank you so much for tuning in. My name is Nicholas Biancolin, and today I'm joined by McMehen and Dimitri Sfyridis. And together, we're going to tell you a little bit about space travel. So, to start us off, I'm going to hand it over to my friend Dimitri to tell us a little bit about how it all began.
Today, there are 18 independent space agencies with the capability to launch a spacecraft. Combined, these 8 organizations cost an enormous total of $62 billion per year, while NASA itself is responsible for $21.5 billion of that total. Let's take a look at how it all began. Following World War II, both Russia and America emerged as the world's greatest superpowers. Each sure that the other was out to conquer the world, the rising tensions brought forth a Cold War between a communist Russia and a democratic United States. This tension put the entire world at unease as Russia turns on their former allies, and an iron curtain is drawn across the continent of Europe. Both the east and west sides of the curtain start to stockpile and test nuclear weapons. However, Moscow and Washington are over 4,000 miles apart, and in the late 40s, missiles could only cover up to a couple of hundred miles. So, both superpowers decide that they need to launch rockets through space to cover the shortfall, although this leads to a new idea. What if rockets could be fitted with a camera to spy on the enemy? The ballistic missile race turned into a race to get the first satellite into orbit. On October 4th, 1957, Russia beats America to the race and launches Sputnik 1. It orbits the Earth 1,440 times for about 2 months, until it travels further than the distance between Earth and Mars and falls out of the sky. Americans are terrified at the fact that a Soviet satellite is orbiting above their heads, as the nuke could be next. So, to reassure its citizens, the United States establishes a new agency and launches NASA, National Aeronautics and Space Administration, who make the announcement that they plan to be launching a human into space before Russia. At the time, no one was sure whether or not a human could survive the cruelties of space travel. Scientists from both America and the Soviet Union began to experiment launching a variety of animals into space. Although they didn't make it back to Earth, the animals survived their trips through the atmosphere unharmed. Scientists believe that what animals can do, humans can too. When launching a human into space, the gravitational force to penetrate an object through the Earth's atmosphere is 16 times the force of gravity on Earth. A human being blacks out at 5 times the force of gravity on Earth, while the blood networks are crushed at the force required to leave the atmosphere. Space is almost as cold as absolute zero. At this temperature, your blood will start to boil as well as vaporize due to the fact that there is no pressure keeping it a liquid. During re-entry, temperatures caused by friction reach about half as hot as the sun, 5,000 degrees Fahrenheit. So, in 1959, NASA put together a group of courageous military pilots called the Mercury 7. Russia followed suit and formed a team led by Yuri Gagarin, a 26-year-old fighter pilot who portrayed the idea of Soviet communism. Both space programs suffered major setbacks until April 12, 1961. Major Yuri Gagarin leaves the world in awe after a safe flight to and from Earth's orbit. Once again, the Soviets are more successful than their competitors. However, 3 weeks later, the Americans sent one of their own to space, Alan Shepard. His spacecraft only pierced the atmosphere while being a much shorter flight than Gagarin's. Nevertheless, Americans become much more optimistic. In November of 1961, President John F. Kennedy makes the announcement that a large amount of resources will be committed to landing the first man on the moon, named Project Apollo. NASA's budget is doubling every year, with full support from their president. On November 16, 1963, President Kennedy visited Cape Canaveral to showcase his support in the American government space program. 6 days later, he was assassinated. Americans lose interest in the moon race as it is becoming very costly, and NASA loses its largest advocate. To make matters worse, in 1964, the United States deploys troops in Vietnam in an effort to stop the spread of communism. Meanwhile, the Soviets have successfully put the first object on the moon, completed man's first spacewalk, and flew the first woman to travel to space. America's only hope for a win in the space race is to have the first man land on the moon.
Thanks for that awesome history, Dimitri. Now let's talk a little bit about the moon landing and what comes to mind. So obviously, the first thing that comes to mind with the moon landing is, boom, this guy. Well, not exactly this guy, but rather who he was based on, who is Major Buzz Aldrin. And really, more specifically than that, we're talking about his partner in the mission, who was Neil Armstrong, and specifically, the first man to ever walk on the moon. Now, fun fact about Armstrong, his mission was actually number 11 of all the Apollo missions. Well, not technically, because as you can see, there's a gap between 1 and 7. But let's go through a history of all of the Apollo missions. So, starting with Apollo 1, it was set to launch in the spring of 1967. But unfortunately, this mission never left the ground, as on January 27, 1967, a fire broke out during a simulation which killed the entire crew. Now, moving forward to Apollo 7, you'll notice we've skipped mission numbers 2 to 6. And that's not because someone at NASA forgot how to count. I mean, they'd have bigger problems if that was the case. But these other missions, 2 to 7, were actually renamed as Saturn missions, as they were non-manned missions to test systems up in space. And so, we're on to Apollo 7. On this mission, the 3 crew members ran a number of tests on spacecraft systems, and were also the first people to be on TV while in space. Pretty neat. Moving forward to number 8, this mission was initially supposed to be another one of Saturn's unmanned missions. However, after growing concerns that the Soviet Union was going to launch cosmonauts around the moon, NASA changed this mission from a computerized flight that would only orbit the Earth to a manned flight that would orbit all the way around the moon. And on this voyage, the crew took this iconic picture known as the Earthrise. I think it looks pretty neat. Moving on to Apollo 9, and at this point, once NASA had completed the feat of sending astronauts around the moon, they began seriously preparing for landing astronauts there. In this mission, astronauts tested the lunar landing module, as well as tested the spacesuits that the astronauts would wear on their moonwalk. After 9 comes 10, and this mission was basically a dry run of the moon landing, without actually landing on the moon. Doing this, they made sure everything worked, and if it didn't, they'd go back and fix it. And as well as that, this mission also had the fun feat of being the first color television display from space. Really cool. And now we come to America's favorite one, Apollo 11, the mission where NASA finally lands a man on the moon, achieving John F. Kennedy's goal, and Neil Armstrong says his famous line, "One small step for man, one giant leap for mankind." Moving forward, we also have Apollo 12, which is significantly less popular, because how do you top putting a man on the moon for the first time? So in this mission, the crew just left some sensors on the moon and also retrieved an older robotic lander named Surveyor 3 to study the effects of the moon's environment on the lander. Next comes Apollo 13, and while there are more missions after this one, we're going to stop at Apollo 13 because this mission is significantly important than the rest, as it was supposed to explore a hilly region of the moon known as the Fra Mauro region. However, while in flight, an oxygen tank on the ship exploded and severely weakened the ship. However, given this failure, the crew was still able to successfully return to Earth without the loss of any lives. The story of Apollo 13 is an incredibly interesting one that we unfortunately do not have any time to go over. But to learn more about it, I highly recommend you check out the Tom Hanks movie named Apollo 13. And thus ends our summary of the moon landing and Apollo missions. Now I'm going to hand it over to Ethan to talk about our space shuttle program.
The Space Shuttle program began on April 12, 1981 with Columbia performing a shuttle systems test and ended on July 8, 2011 with Atlantis delivering supplies to the International Space Station or ISS. The program consisted of 5 reusable shuttles named Columbia, Challenger, Discovery, Atlantis, and Endeavour. Altogether, the Space Shuttle fleet flew 135 missions to repair, build, or recover satellites and to help contribute to the engineering of the ISS. During liftoff, the space shuttle is made up of 3 components: the orbiter, the external fuel tank, and the booster rockets. Out of 135 missions, 2 missions ended in catastrophe: Challenger on January 28, 1986, and Columbia on January 16, 2003. 73 seconds after liftoff, Challenger exploded, instantly killing its 7 crew members, including schoolteacher Sharon Krista McAuliffe, who was selected through a nationwide contest to be the first private citizen to fly into space. As an immediate consequence of the catastrophe, the program shut down all missions until 1988 to investigate the mechanical failures as well as to enact organizational changes. Upon investigation, NASA found that a hot gas leakage from the booster rockets ignited the orbiter's external fuel tank. This event was experienced live and shocked the world. Now on to Columbia. When returning from orbit upon completion of their mission, Columbia broke up 60 kilometers over Texas, killing its 7 crew members, including first Israeli astronaut Ilan Ramon. Like Challenger, the program was grounded to investigate the mechanical issues and enact organizational change until its return with Discovery on July 26, 2005. The investigation revealed that a piece of insulation had torn from the orbiter's external fuel tank and penetrated the left wing. After re-entering the atmosphere, the heat caused by friction from the air caused the left wing's destruction, which led to the breakup of the orbiter. Despite these 2 missions, the Space Shuttle program did a lot of good for the world. The program created the first international collaboration between the USA and Russia after the Cold War and collapse of the Soviet Union. The program led to advances in space technology. The program inspired and united the world in the name of space travel. And the program made the construction of the ISS possible. But how exactly did the Space Shuttle travel? Now we get into the physics. For liftoff, the space shuttle is composed of the orbiter, the external tank, and the booster rockets. To project the shuttle into space, the external tank contains hydrogen and oxygen that combust to form water vapor that exits the nozzle of the engines and produces 31,000 kilonewtons, or 7 million pounds of thrust. The basic premise behind the projection of the space shuttle is Newton's third law of motion. For every action force, there is an equal in magnitude and opposite reaction force and direction. The action force is the thrust, and the reaction force is the rocket's propulsion. Once the shuttle is in space, the orbital maneuvering systems, OMS, engines use monomethylhydrazine fuel and nitrogen tetroxide as the propulsion to place the orbiter in a specific orbit. At this point, the space shuttle's previous momentum and kinetic energy provide the orbiter's velocity with the speed of 28,000 km per hour, with gravity acting as a centripetal force pulling the shuttle to Earth. As a result, we end up with centripetal acceleration around the Earth, or in other words, an orbit. That's the physics for liftoff. When landing, we get into aeronautics as well as physics. Once again, Newton's third law of motion is used, but this time to decelerate the orbiter using the OMS system to increase the gravitational potential energy. As a result, the gravitational force increases and the space shuttle falls to Earth. While traveling toward the atmosphere, the orbiter is directed at an angle of depression of 40 degrees from its original heading to face the atmosphere. While traveling 28,000 km per hour into the atmosphere, the orbiter experiences 1,650 degrees Celsius of heat from the friction caused by air. To protect the orbiter from disintegrating, the orbiter is covered with insulating materials including reinforced carbon-carbon on the underside and wings, black surface insulation tiles around the windows, white Nomex blankets on the doors and portions of the upper wing, and low-temperature white surface tiles everywhere else. All of this is to build a high heat capacity to withstand the frictional heat. Once the orbiter successfully enters the atmosphere, it flies like an airplane. Above 40 kilometers from the Earth's surface, the space shuttle flight computers fly the shuttle while the commander works out navigation. Once the shuttle reaches 40 kilometers, the control is given to the commander. The commander steepens the angle of descent by 20 degrees until the orbiter is 610 meters above the ground. The commander then pulls up the nose and activates the landing gear. When the orbiter touches down, the parachute and brakes decelerate the space shuttle. Altogether, the landing process is calculated and executed using Newtonian kinematics and dynamics through acceleration due to gravity, velocity, momentum and energy, frictional forces, and Newton's laws. Now I pass the stage to Nicholas.
Thank you, Ethan. Now let's talk about the International Space Station. As we've got all the history about space shuttles, and space shuttles helped build the space station, let's talk a little bit about what it is and why it's so awesome. So, in short, the International Space Station, or ISS for short, is pretty much what it says it is. It's a massive habitation in space that orbits around Earth. Its primary purpose is a science lab where astronauts can conduct experiments. A few facts about the space station: it weighs 925,335 pounds. Lengthwise, it's about as long as an entire American football field, and each of its solar arrays is 72 meters long. Pretty neat. A really cool thing about the ISS is that no one country owns it and built it. It is and has been a collaborative effort by 5 space agencies from 15 countries, proving once again how space can unite countries together. One final cool thing is that Canada has contributed to the space station is the Canadarm2, which is Canada's most famous technological advancement in the field of robotics. While the initial Canadarm1 was designed for use on the Space Shuttle program, like Ethan mentioned earlier, the arm was actually used in space to build the ISS during its first construction. The new Canadarm2 is actually permanently mounted on the ISS and was also used to build extensions onto the ISS. Now I'm going to pass the stage to Dimitri to talk about the Perseverance rover.
NASA's Perseverance rover mission began on July 30th, 2020 as a 2-year effort to explore Mars using robotic technology. Since its landing on Mars 8 months later in February of 2021, it has been searching for signs of microscopic past and present life on Mars. The rover uses a drill on the surface of Mars to collect core samples of rock and soil, of which will be further examined when they return to Earth. To do this, the rover stores the sample tubes on board until NASA decides on a specific depot location that is easily recognizable using landmarks and precise coordinates from orbital measurements. The Perseverance rover then deposits the samples on the surface of Mars to be available for pickup. Currently being designed at NASA's Space Flight Center in Huntsville, Alabama, is a sample return campaign. The lander in development will touch down at the depot location where a robotic arm will pack the samples into the tip of a rocket. The rocket will then deliver the sample capsule to Mars' orbit, where an ESA orbiter will be waiting to receive and deliver the payload back to Earth. The rover also provides us with the opportunity to gather knowledge that will help future human expeditions to Mars. This includes a testing method to produce oxygen for the Martian atmosphere, as well as identifying resources such as subsurface water. The rover will also improve landing techniques and characterize environmental conditions. To travel through space, the rover was encased in an aeroshell that consisted of a heat shield and a conical back shell. When entering Mars' atmosphere, the heat shield had to endure 3,800 degrees Fahrenheit because of the effects of friction, turning the spacecraft's kinetic energy into thermal energy. After it entered the atmosphere, a large parachute is deployed to slow the aeroshell from a speed of Mach 1.7 to about 320 kilometers an hour. Then, the heat shield is dropped away from the back shell, and a sky crane is performed to gently lower the car-sized Perseverance rover into the Jezero crater. NASA's Perseverance rover allows us to substantially further our knowledge of Mars. This mission brings us one step closer to human expeditions to Mars, and in the event that Earth becomes uninhabitable in the future, human civilization has a chance to prosper on a new planet. It also provides us with the opportunity to significantly advance our insight of organisms that may have lived on Mars, as well as substances that cannot be discovered on Earth. The Perseverance rover is a large step to better understand not only Mars, but our entire universe.
Artemis is the deep space exploration program that will return humans to the moon and in the near future send humans to Mars. The Artemis program as a whole has developed new spacecrafts and technologies for space travel, including the Orion spacecraft, the Space Launch System (SLS) rocket, the Getaway Lunar Orbital Craft, the Human Landing System, and the Artemis Base Camp, which will be stationed on the moon. There are currently 3 Artemis missions, but I'll be focusing exclusively on Artemis 1. The purpose of Artemis 1 is to test NASA's deep space exploration systems that were built in collaboration with other national space agencies. These systems are the Orion spacecraft, the SLS rocket, and the ground systems at Kennedy Space Center. Artemis 1 will be an uncrewed flight test. The launch date is March 12, 2022, which is fast approaching. Before I get into the flight plan and physics of the flight, I first need to describe the spacecrafts. Orion is composed of the crew module, service module, solar wings, and launch abort system. The crew module is the habitable component of Orion that can hold 4 people and that has a heat shield that can withstand 2,760 degrees Celsius. The service module provides power, thermal control, air, water, and propulsion. The propulsion is composed of a main engine capable of 6,000 pounds of thrust, 8 auxiliary engines capable of 110 pounds of thrust each, and 24 reaction control thrusters. The solar wings generate 11 kilowatts of power for the spacecraft. The launch abort system contains an abort motor capable of 400,000 pounds of thrust and that can go from 0 kilometers to about 652 kilometers per hour in 2 seconds. The purpose of the launch abort system is to activate within milliseconds in case of emergency to pull the crew module to safety and then enact a safe landing. The Space Launch System, SLS, is the most powerful rocket that can produce 8.8 million pounds of thrust to make Orion travel at a speed of 39,429 kilometers per hour. The SLS rocket is 98 meters tall and weighs 5.75 million pounds. The goal of the SLS is to launch Orion into orbit 64,374 kilometers beyond the moon. Aside from Orion, the SLS is composed of many parts, but I'm only going to highlight the 4 RS-25 engines, the core stage, the 2 rocket boosters, and the interim cryogenic propulsion stage, ICPS. The core stage is about 65 meters tall, about 8 meters wide, and stores 2,763,350 liters of supercooled liquid hydrogen and liquid oxygen that fuel the RS-25 engines with the same reaction and Newtonian physics as the space shuttles. The 4 RS-25 engines are designed for the propulsion of the SLS core stage, providing 512,000 pounds of thrust. The 2 rocket boosters provide more than 75% of the SLS thrust during the first 2 minutes of liftoff. The ICPS is the system that will propel Orion out of Earth's orbit. The ICPS uses the RL-10 engine that is powered by liquid hydrogen and liquid oxygen to generate 24,750 pounds of thrust to push Orion. Orion and the ICPS are connected via the Orion stage adapter. Now that I've explained the spacecrafts, let's talk about flight. The SLS engines are activated, and after 90 seconds of liftoff, the maximum thrust of 8.8 million pounds is reached, propelling the system through the atmosphere. 2 minutes into the flight, the rocket boosters are safely jettisoned. 3 minutes and 40 seconds after liftoff, the launch abort system is jettisoned. 8 minutes and 14 seconds in, the core stage engine shut down, and the core stage separates from Orion. Once Orion passes the ISS orbit, the solar panels are deployed. During the perigee raise maneuver, the thrust provided by the ICPS ensures an orbit around Earth, so that way Orion doesn't fall towards the Earth. During the translunar injection stage, the ICPS engine will thrust Orion for 20 minutes to increase Orion's speed by 2,743 meters per second to propel Orion out of Earth orbit and to the moon! Soon after, the ICPS and Orion stage adapter separate from Orion together. Orion flies past the orbital debris field, GPS orbit, communications satellites, and through Van Allen's radiation belts. Orion then navigates the deep space environment on the way to the moon. Once Orion reaches the moon, the service module makes a critical lunar gravity assist maneuver that makes Orion enter an orbit about 100 kilometers from the moon's surface. After a successful lunar gravity assist maneuver, Orion enters its distant retrograde orbit, DRO, where systems will be tested fulfilling the Artemis 1 mission purpose. Orion then exits its moon orbit with another lunar gravity assist and service module engine firing. Orion's trajectory during this time is adjusted to target Earth's atmosphere and Pacific Ocean landing. The service module is jettisoned once Orion reaches Earth's orbit. The heat shield will be oriented to face the atmosphere, and upon re-entry, Orion will hit the atmosphere at 39,429 kilometers per hour. The decelerating force caused by the air of the atmosphere is up to 9 times stronger than the force of gravity, producing 2,760 degrees Celsius of heat due to friction. Once Orion enters the lower atmosphere as signaled by a sonic boom, the drogue chute deployment begins, releasing a series of parachutes, decelerating Orion to a safe landing. Altogether, Artemis 1 includes a lot of Newtonian kinematics and dynamics. Before the flight occurs, the satellite orbital speed of the moon is calculated to plan and ensure Orion's orbit is successful. During liftoff, Newton's laws come into play, as well as energy and momentum through calculations of thrust required to accelerate out of the atmosphere. To at first stay in orbit and not fall back toward Earth, centripetal force and acceleration have to be calculated and used to successfully remain in orbit long enough to circle the Earth. To actually escape from Earth, centripetal acceleration is increased and used as a slingshot acting on Orion to propel it towards the moon. To fly to the moon, the binding and escape energies need to be calculated to determine the necessary kinetic energy and momentum needed to escape Earth's gravitational field once the proper centripetal acceleration is acquired. Once at the moon, the same process of centripetal acceleration, centripetal force, satellite orbital physics and speed, universal gravitation, and Newton's laws are calculated and integrated into the flight to successfully project Orion into the designated DRO. Once Orion returns to the moon at the end of the DRO, Newton's laws, centripetal acceleration, binding energy, and escape energy are all calculated to produce enough kinetic energy and velocity from the service module to propel Orion back toward Earth. When Orion reaches Earth, universal gravitation is used to re-enter the Earth. To protect Orion, the heat shield is built with a high heat capacity to withstand the insane heat produced by frictional force caused by the air. And finally, Newtonian kinematics of velocity and acceleration are used to decelerate Orion into a safe landing in the Pacific Ocean. All in all, Artemis 1 is a very complex physics problem that I am simplifying to my best abilities so that we can understand it all. However, it is this exact challenge that motivates NASA and space agencies alike to do Artemis. Artemis 1 will create and has created a new industry in the economy in lunar science and engineering that will provide tons of jobs around the world. The creation of new jobs will all help space agencies like NASA to explore the moon and in the future Mars. Artemis 1 provides inspiration to the world by showing the magnificent things we can accomplish, like building an environment on the moon for astronauts to live in and conduct research. Artemis 1 also helps the advancement of science and knowledge by better understanding our universe and planets by conducting research on different celestial environments. And finally, Artemis, like most space programs, unites the world in peace to contribute to the goal of space travel.
And that just about concludes our presentation on space travel. Thank you so much for paying attention. And now, to reward you for listening to almost 20 minutes of us droning on about space travel, we'd like to introduce our Rocket Lab activity. And the best part about this Rocket Lab activity is that it is a lab activity and therefore has no lab report. Woo! Everyone loves no lab reports. Fantastic. So, you should be given a handout which will have all the instructions to complete the lab. But let's watch this video to get an understanding of it first. looks pretty cool, right? Before we start this is going to be a video of our very own Ethan McMehen demonstrating how to do the lab for us. Let's see his results. There we have it. A fun, fantastic rocket lab. Now, we've reached the end of our presentation. Thank you so much for paying attention. I've been Nicholas Biancolin. With me has been Ethan McMehen and Dimitri Sfyridis. And together, we've told you about space travel. Have a fantastic day.